This video is on simplifying complex fractions. Going through this little handout here, we'll just talk about some definition and then we'll actually do some examples. The first thing you see is the definition of a complex fraction is one that has fractions in the numerator, the denominator, or both. So they're essentially fractions within fractions. So you could have a fraction in the numerator, a fraction in the denominator. You could have multiple terms that are fractions in the numerator or denominator, or both. All right, so just some examples, if you were thinking of what these might look like. If I had something like 5/7 over 3/4, right? That would be a complex fraction. I have a fraction in the numerator and denominator. I could have something like x plus y over 2 over 1 plus 5 over x, right? That would be a complex fraction. I have fractions in the numerator and denominator. Or it could be something like, 5 plus 3 over x over, say, y squared. That's still a complex fraction. We have a fraction in the numerator. Even though we don't have a fraction in the denominator, it's still complex because there's a fraction within a fraction. So when we say we want to simplify these, typically what we want to do is you just want to have a single fraction at the end. You shouldn't have any fractions within fractions, in other words. And there's two ways you can do it. What I'm going to call method 1 and method 2. And for quite a few of the examples, I'll show you both methods, and then I might just say pick one or the other. You should get the same answer either way. For method 1, we have simplify both the numerator and denominator to single fractions, and then multiply by the reciprocal of the denominator. So, for example, if I was looking at this second one I showed up here, I would want to simplify this to a single fraction by adding these together, kind of like we learned earlier in the course. And the same thing in the denominator, I try to get these to be a single fraction. Once it's a single fraction over a single fraction, something like we have here, then the way you think about it is if you're dividing a fraction by fraction, you multiply by the reciprocal of the denominator here. So it's really, you get single fractions in the numerator and denominator, and then you divide by you multiply by the reciprocal. The second method is to multiply every term in the entire complex fraction by the LCD of all fractions that appear in the numerator and denominator. So I would find the LCD for this whole thing and then multiply the LCD to every single term in here. What that does is it clears fractions because the LCD will divide evenly with all those denominators and you'll just get a single fraction. So we're going to go through and do a few examples now showing how these methods work. So looking at the examples here, we might try to do this without any variables first, just to show how it works. So if I said to simplify, and I gave you 3/4 plus 1/6 over 5 plus 1/8. So to simplify a complex fraction, remember in the end of this, I want this to be just a single fraction. And we have to pick which method we'll use. I'll pick to use method 1 here. Now remember what method 1 said. Method 1 said that we were going to rewrite the numerator and denominator as single fractions and then multiply by the reciprocal. So really what you want to do is you want to add through the numerator. So if I wanted to add through the numerator 3/4 plus 1/6, to add fractions we need a least common denominator, an LCD. And between 4 and 6 in the denominator, the smallest number they both go into evenly is 12. So I want this LCD to be 12. So, you're going to have your main fraction bar, which separates this here. But then in the numerator, I know my fraction is going to have a denominator of 12. And then you have to ask yourself, okay, how do I get to that denominator, right? So 4 times what gives me 12? Well, 4 times 3 would give me 12. So then in the numerator, I have to do 3 times 3. Don't just change the denominator, right? You have to also manipulate the numerator by multiplying by the same value. So 3 times 3 gives you 9. Plus, because we have a plus sign here, and then 6 times what gives you 12? Well, 6 times 2 will get you to 12, so then the numerator 1 times 2 will give you 2. So you have 9 plus 2 all over 12. And to write that as a single fraction then, right, what's 9 plus 2? Well, that's 11. So in the numerator, I wrote it as a single fraction of 11 over 12. In the denominator, we're going to do something very similar. We're going to add the 5 plus the 1/8. Now 5, remember, as a fraction is really 5 over 1. And you want the LCD to add these together. Well, the least common denominator between 1 and 8, well, it's going to just be 8. So I know that this is going to be a fraction that's over 8 here. And you have to ask yourself again, how do you rewrite this? Well, 1 times what gives you 8? Well, 1 times 8 gives me 8. Whatever I do in the denominator, I should do in the numerator. 5 times 8 will give me 40. So that's rewriting the first fraction. Plus 1/8. Well, 8 times 1 just got you 8, so 1 times 1 just gives you 1. So it didn't have to be changed for the second one because you already had the common denominator. So this ends up being 41, right? 40 plus 1 is 41 over 8. So now we have a single fraction over a single fraction, and we know that when we have a fraction divided by a fraction, this is our keep, change, flip, right? You multiply by the reciprocal. So we keep the first one as 11/12. We change division to multiplication, and the reciprocal, meaning the flip of the 41 over 8, is 8 over 41. Now once you've done this, you want to simplify like you normally can when you're multiplying fractions, which means you can cancel common factors to the numerators and denominators. Well, 11, the only factors it has is 1 and 11. Nothing cancels there. Here, 8 and 12, they share a common factor of 4. 8 divided by 4 will give me 2. 12 divided by 4 will give me 3. And then 41, again, the only factors it has is 1 and 41. So remember how you multiply. Straight through the numerator, 11 times 2 is 22, over straight through the denominator, 3 times 41 is 123. Now you should check to see if that simplifies. If you simplified earlier, a lot of the times this will not, but you should make sure. But in this case, it doesn't. So we got 22 over 123. So method 1 really involved rewriting the numerator and denominator as single fractions by using addition, and then multiply by the reciprocal. If you divide by a fraction, you multiply by the reciprocal. That's our keep, change, flip, is the way you might have heard it before. So now let's do the same example, but with method 2, just to show how both work. So I'm still going to simplify 3/4 plus 1/6 over 5 plus 1/8. And this time we're going to use method 2. So to simplify using method 2, remember what it said to do. It said multiply every term by the LCD of all the fractions that appear. So first off, I'm looking at all the fractions in numerator and denominator. The 5 is over 1, so you don't have to worry about that. It's not a fraction per se. So I'm looking for the LCD of 4, 6, and 8. Well, the smallest number they all go into evenly. The LCD here for 4, 6, and 8 is 24. And you could use larger numbers, you just have to reduce more at the end if you did. As long as it's a common denominator, it'll work. So the LCD is 24, and I said to multiply it to every single term. That's what method 2 says to do. So I'm going to take 24 times the 3/4, 24 times the 1/6, 24 times the 5. So you multiply it to every term. Even if it's not a fraction, you multiply it to every term. That's why I underlined it in the definition. And 24 times the 1/8. And when you multiply this, right, the real thing you're doing is you're actually dividing with a denominator to cancel and then multiply through the numerator. So 24 divided by 4 will give me 6, and then 6 times 3 makes this first term 18. Plus, now if you didn't do it that way, you could do 24 times 3, which is 72 divided by 4, and it still gets you 18. It's easier to cancel first though. 24 divided by 6, which gives me 4, and then 1 times 4, well that's just going to be plus 4. And now notice we don't have any fractions in our numerator. That was the point, we wanted to clear fractions. For the denominator, 24 times 5, you might need to do this on your calculator. 24 times 5 comes out to 120. Nothing cancels here. If you don't have a fraction, you just multiply them together. Plus here, 24 divided by 8 will give me 3, and then 1 times 3 is 3. So now you've cleared fractions. So now all you got to do is add the like terms. Don't start canceling things out. Remember, you can't cancel if it's addition or subtraction. It's only if it's multiplication in fractions. So 18 plus 4, well that's 22. 120 plus 3 is 123. You should always check to see if this can simplify any further. In this case, we know 22 and 123 don't share any common factors other than 1. So two methods get you to the same place, right? We end up in the same spot. The first method is rewrite each fraction as a single fraction, then multiply by the reciprocal, right, through division of fractions, which is multiply by the reciprocal of the denominator. The second method is clear fractions first, then, combine like terms, then simplify at the end if you can. Either method's okay. It's your choice on which one you prefer. Let's take a look at a few others. So if I said to simplify Right, the directions here will be simplify. Simplify means you don't want any complex fractions. If I had 5 over x squared minus 2 over x all over x squared over 6. So in this case, you have to pick the method you want to use first. Doesn't matter what you pick, but you got to pick one of them. Don't blend the methods together. I'll use method 1, and then I'll show you again with method 2, just to show you both. So for method 1, remember that was to combine the numerators and denominators into single fractions. So the denominator is already a single fraction, so I don't have to worry about that. For the numerator to get a single fraction, I'm combining the 5 over x squared minus 2 over x. Well, to subtract those, I need an LCD. Well, what's the LCD for x and x squared? It's just going to be x squared. So the first one, the 5 over x squared, already has the common denominator. Remember, when you're looking at this, you want the highest power of the factor you see, so that's why it's x squared. So when I go to rewrite this, right, here's my main fraction bar. 5 over x squared, I'm going to keep this 5 over x squared. Right, and actually I can write the whole thing over x squared because that's going to be my common denominator. Minus, now, x times what gives me x squared? Well, x times x will give me x squared, so then I have to do the same thing in the numerator, so it's going to be minus 2 times x, which is minus 2x. So we have 5 minus 2x all over x squared. And then this is over x squared over 6 because it's already a single fraction. And now remember what happens. Now I've got a single fraction divided by a single fraction. So then you can multiply by the reciprocal. So we keep the first, 5 minus 2x all over x squared. And then you multiply. When you divide by a fraction, you multiply by the reciprocal, so it becomes 6 over x squared. And then, if anything cancels, you cancel it. Remember, these x squareds are on the same level, so you can't cancel them out with each other. The other thing to notice is that you can't cancel any of this x with any of these because that, is one whole factor of 5 minus 2x. So with 5 minus 2x times 6, which I'll write is just 6 times 5 minus 2x, you can leave that in factored form. X squared times x squared is x to the, remember when you multiply two things at the same base, you add their exponents, so this would be x to the 4th power. And then if this is reduced at all, you would reduce it, but in this case, it does not, so you could leave it, and that would be your answer using method 1. If you distributed the 6 in, that's not a big deal, but you would always want to try to factor it to see if it cancels out at all. Let's take a look at the same problem using method 2. So if I put 5 over x squared, so again the directions are simplify. So if I said 5 over x squared minus 2 over x all over x squared, x squared over 6. Okay, so method 2, remember method 2 said we're looking for an LCD for all the fractions that appear. So in this case, the LCD for all the fractions, x squared, x, and 6 are my denominators, so the LCD will equal, well, you need the 6, and then between x and x squared, you need x squared, the highest one you see. Don't make it x to the 3rd, then you didn't pick the lowest. It also might not simplify as easily. So now you take 6x squared, and we're going to multiply it to every term. Remember, that's what method 2 says to do. So I'm going to multiply by 6x squared, multiplying by 6x squared, and I'm going to multiply this by 6x squared. And when I do that, now I'm able to cancel the denominator. That's really the reason we do this, right? Is to clear fractions. So here we have 6x squared times 5 over x squared. The x squareds will cancel. And I'm really just left with 6 times 5, which is 30, minus here 6x squared times the 2 over x. Well, one of these x's will cancel with one of these, so there's still an x there. So we got negative 2 times 6x would be negative 12x. That's the numerator. All the fractions are cleared. Over the denominator, 6x squared times x squared over 6. The 6's cancel because they're on different levels. You can't cancel those x squareds because they're both on the same level. You only can cancel with the denominator if you're multiplying something to it. So x squared times x squared is what's left, which is x to the 4th power. Now, you should check to see if this simplifies. If you know it doesn't simplify any further, then you'd be okay to leave it. But remember, when you're checking to see if it simplifies, you factor out. If I factor out a GCF here, it would be 6. We'd be left with 5 minus 2x all over x to the fourth, and none of that cancels. Notice that's the same answer we had above. So either of these would be okay. And either method is okay. Typically, people prefer method 2 because it clears all the fractions out right away and then you're not working with them anymore. But if you prefer method 1, that's fine. Just make sure you show the appropriate work for either method. The other part about this that's really important is that don't blend the methods, because if you blend the methods, then there will be confusion between what you're supposed to do. In method 1, remember, it's a rewrite each fraction, or each numerator and denominator as a single fraction. In method 2, it's clear the fractions out completely and then just simplify. All right, so they are different things. Let's take a look at another one here. If I said, for example, to simplify, and I had 1 over x squared minus 1 plus 2 over x plus 1 all over x. So first off, it's a complex fraction. Even though we don't have a fraction in the denominator, if you have fractions in the numerator, it's still a complex fraction if they appear in one place. If I'm looking at this, you have to pick which method you want to use, method 1 or method 2. I will pick a method for us. I'll pick method 2, but you could have picked method 1 and that'd be okay. So for method 2, if I was to do this, right, and I'll write method 2 here this way, you know which method I'm using. I need an LCD for all fractions that appear. When we try to find an LCD, you have to remember that the first thing you should do is factor the denominators completely. This x squared minus 1 isn't factored. So in the previous examples we didn't have multiple terms, but if this can factor, you need to factor it. So first thing I'm going to do is just rewrite this as x squared minus 1. That's a difference of perfect squares. So this will be x plus 1 times x minus 1. So you should be checking to see how that factors. Plus this is 2 over x plus 1. And this is all over x. So I didn't do anything except for simplify that denominator. Now remember, for method 2, I need the LCD for all the fractions that appear. Now in this case, the denominator is just x over 1, so you don't really need to use that as a part of the fractions. So the LCD here, well, I see x plus 1 as a factor here, I see it here as well. So you need a factor of x plus 1. Remember, the highest power you see of it is just 1, so don't put it squared, you only need one of them, because the highest power you see of it is 1. I see a factor of x minus 1 here. I don't see that anywhere else, but I need it if it shows up anywhere, so I need a factor of x minus 1. So the LCD is x plus 1 times x minus 1. Now remember what method 2 says to do. Method 2 says take this and multiply it to every term, whether it's a fraction or not. So I'm going to multiply by x plus 1 times x minus 1 to the first term. I'm going to multiply it by x plus 1 times x minus 1 to the second term. And you also have to do it to the denominator. That's the whole reason why it works. The reason this works is because you're multiplying both the numerator and denominator by the same thing, which means that you're really multiplying by 1, and that's what keeps it balanced. So I have to multiply by x plus 1 times x minus 1 down in the denominator as well, even if it's not a fraction. Remember, that's what method 2 says to do. Multiply every single term by the LCD. Once I've done that, remember, for method 2, the idea is that you're canceling denominators, you're clearing fractions. So in this first one, x plus 1 cancels with x plus 1, x minus 1 will cancel with x minus 1. I'm left with just 1 times 1, which just gives me 1. Plus here, 2 over x plus 1 times the x plus 1 times x minus 1. The x plus 1 here will cancel with the x plus 1, and I'm left with 2 times, make sure you have parentheses, x minus 1. Over in the denominator, nothing cancels here. You just want to write them out. X times x plus 1 times x minus 1. Once you have that, now we're going to simplify. By simplifying, I really mean you have to distribute through the numerator, combine like terms, and then factor at the end if you can. So we end up with 1 plus a positive 2 getting distributed through. Make sure you take the sign with it. If that was a negative, you want to bring a negative. So a positive 2 times x will be plus 2x. A positive 2 times a negative 1 makes this minus 2, all over x times x plus 1 times x minus 1. And then combining like terms up here in the numerator and writing it in descending order. 2x won't combine with anything. 1 minus 2 is a negative 1, so I have 2x minus 1 over x times x plus 1 times x minus 1. And if this 2x minus 1 would factor, then you would try to factor and simplify. As this stands now, none of it cancels out. You can't cancel any of it, so you have to leave it as is. So that would be your answer. You could distribute through this, but I wouldn't. It makes it more complicated, and if you make an error there, you'll lose out on the points. The other thing I would point out is that if we used method 1 would indicate that I want to add these two fractions together. If I used method 1 in this case, I would have still had the same LCD, because that would have been the LCD for both of these, but you wouldn't have been canceling things out. You would have actually been rewriting this as x plus 1 times x minus 1 in the denominator, multiplying the numerator by the same thing. You would get to the same answer. It would just take you a couple steps more. This x would be considered over 1 as a single fraction in the denominator. Why don't we take a look at another one? Now you may want to pause the video after I write this and try it on your own. If I was to say simplify we'll look at 6 over x squared minus y squared over 1 over x minus y plus 3 over x plus y. Okay, so I'd pause this and try it out on your own. So if I'm going to solve this, I'm going to try to use method 2. I'm choosing that. You could choose method 1. Method 2, remember, you're trying to find the LCD for all the fractions of the pair, and then you're going to clear fractions out by multiplying. So first thing, if I'm looking for an LCD, is I have to rewrite this using a common denominator. So this would be 6 over, now if I have x squared minus y squared, I want to factor this out to find the common denominator, right? So x squared minus y squared, that's the difference of perfect squares. Make sure you recognize that. So this would be x plus y times x minus y. Here we don't have to factor it all because it's already single terms. So now when we do this, we want an LCD for everything that appears. The LCD here, remember, if the factor appears in any of the fractions, you need it. So the LCD between this, this, and this, well, we have x plus y as a factor here. We also have it here. It's to the first power, so it's just x plus y to the first power. We have x minus y as a factor here. We also have it here. Again, it's to the first power. So we have x minus y there. And then when you find that LCD, remember what you do with it. You multiply it to every single term. So I'm going to multiply by x plus y times x minus y here. I'm going to multiply by x plus y times x minus y here. I'm going to multiply by x plus y times x minus y here. Now when you multiply by this, remember the goal is to clear fractions. So x plus y times x minus y times is 6 over x plus y times x minus y. Well, the x plus y's cancel, the x minus y's cancel. I'm off with just 1 times 6, so this ends up being, if I move this over here, it just ends up being 6 over, right, so now this is my big fraction bar. Here, x plus 1 times x, or x plus y times x minus y times 1 over the x minus y. Well, the x minus y's will cancel, you know, for x plus y times 1, which anything times 1 is itself. So this just be x plus y. If you want to see it, I can write the 1 here just in case you don't realize, you know, there's a number that you would multiply through normally if it was any other whole number value here. In this case, we're multiplying 1 because it's 1. Plus, because this is plus, we have 3 over x plus y times the x plus y times x minus y. The x plus y's cancel, so you're left with plus 3 times x minus y. And notice fractions are gone. That's good. If your fractions don't clear at this step, it means you didn't pick a good LCD. In other words, you didn't pick a common denominator. So now we want to simplify this. You end up with 6 over 1 times x is just x. 1 times y will be plus y. And here you're distributing a positive 3, so you get plus 3x. And plus positive 3 times a negative y makes this minus 3y. You want to combine like terms. So we end up with 6 over x plus 3x is 4x. Y minus 3y is negative 2y. And then the last thing you need to do is try to simplify this. Is there anything you can factor from the denominator? Well, in this case, there is a greatest common factor. The greatest common factor here between 4x and 2y is 2. Let's see if that helps us at all. So we ended up with 6 over, factoring a GCF of 2 out, we'd end up with 2x minus y. And then you should notice that now you can cancel between the 6 and the 2 that's out in front, because now it's multiplication, so that's when you're allowed to cancel. So 6 divided by 2 would give me 3, 2 divided by 2 gives me 1. So I'm left with 3 over 1 times 2x minus y, which is just 2x minus y. And that's the answer. Remember, that's using method 2. Method 2 is find the least common denominator for all the fractions that appear in the entire complex fraction, and then multiply it to all the terms to clear fractions. Then simplify. And maybe we'll take a look at one more here. So if I said to simplify, this one here, if I had 4 over x squared plus 6x plus 8 plus x over x plus 2 all over 1 over x plus 1. So again, you might want to pause this and try it on your own. Then check your answer after. You have to pick a method to use. All right, it's up to you which method you would like. I will go through and choose method 2 here. If I chose method 2, first thing I want to do is factor out the denominators because I need to find the LCD for all the fractions. So just factoring this out, I'd have 4 over x squared plus 6x plus 8. You don't have a GCF, you see 3 terms. X squared in front means this is x times x. What multiplies 8 and adds a 6, so this will be plus 2 and plus 4. 2 times 4 gives me 8, 2 plus 4 gives me 6. Plus here I'll write this as x over x plus 2 still. And this is all over 1 over x plus 1. So if I'm using method 2, remember I want LCD for all the fractions, so my LCD here, thinking about what that would be, you need every factor that appears in any of them present. So we have x plus 2 as a factor here. I also have as a factor here. I don't have it here, but it appears anywhere you need it, so we need x plus 2. It's the first power in both cases, so you just need the first power. Here I have a factor of x plus 4, so you definitely need x plus 4. It's the only place we have it. And then we also need x plus 1, because we have a factor of x plus 1 down here. It's the only place we have it. So now we multiply every single term by this LCD. So I'm multiplying by x plus 1 times, well, I should really do it in the same order. X plus 2 times x plus 4 times x plus 1 here. I'm also multiplying by x plus 2 times x plus 4 times x plus 1 here. And I'm multiplying by x plus 2 times x plus 1 times x plus 4 here. Now I wrote this out of order by mistake, but it doesn't really matter. Multiplication is commutative. As long as you have all 3 factors present, it doesn't matter which order you write those in. Now let's clear fractions, because that's the goal, right? That's why we do this for method 2. So if I have x plus 2 here and x plus 2, those cancel. I have x plus 4 divided by an x plus 4, those cancel. So I'm left with really 4 times just x plus 1 for that first term. Plus for the next term, I see I've got x plus 2 here. We'll cancel with the x plus 2 down here. So I'm left with x times, and what I have left here is x plus 4 times x plus 1. Over, down the denominator, the x plus 1's cancel. So I'm left with x plus 2 times x plus 4. Really 1 times that, right? But 1 times that's just going to be itself. Now, once you're here, you want to simplify the numerator as much as possible. The easiest thing to do is if you have a common factor, to factor it out. So something that you could distribute through this, and you could distribute through here, but then you're going to have to factor out again after, and you might not know how to do that. But if you notice these both have a common factor of x plus 1, I would factor that out now. So you can factor out x plus 1 here, because this term and this term both have x plus 1. And then we factor out x plus 1, well, what's left? Well, 4 times x plus 1, factoring out the x plus 1 just leaves you with 4. Plus here, you factor out the x plus 1, so you're left with just x times x plus 4. And we'll distribute that through in a minute. This is all over x plus 2 times x plus 4. Remember, you want this in factored form at the end, so that's why it's important to think about factoring when you're doing this. Now, once you've factored this out, you should simplify the inside of this. You can't start canceling because this is still not just a product, right? There's addition in here. So we're going to distribute the x in, and we'll keep everything else the same. So when I do that, I'll have, this will be x plus 1, times, here I'll be left with 4 plus x squared, distributing the xing, and then x times 4 will be plus 4x. All over here we have x plus 2 times x plus 4. And then you should recognize that this isn't in descending order, so you want to write this in descending order. So really what you have is x plus 1 times x squared plus 4x plus 4 all over x plus 2 times x plus 4. And then you have to check, once you factor out the x plus 1, does what's left inside of here factor? Well, x squared plus 4x plus 4, you took out the GCF of x plus 1 already. It has 3 terms. You don't see a value for your x squared, so you're going to try to factor that with 2 sets of parentheses. So x plus 1 stays, and then here, factoring this, we have x times x, but multiplies to 4 and also adds a positive 4. Well, that's 2 and 2, so x plus 2 times x plus 2. This is over x plus 2 times x plus 4. And then now you can cancel common factors of both the numerator and denominator. Well, one of these x plus 2's cancels with 1 down here. You can't cancel them both. If none of them canceled, you want to write this numerator one as x plus 2 quantity squared. So I'm left with this. I have x plus 1 times x plus 2 over down here x plus 4. You don't need parentheses around it because you're just multiplying 1 to it. So that would be it. That's your answer. If you wanted to distribute through and FOIL this, you could in the numerator, but you don't have to. This is a simplified form. So, kind of a little different in this one because we had to factor out that x plus 1 as the GCF here. If you didn't factor out the x plus 1, you would have multiplied through here. You would have distributed through and FOILed this, distributed the x through that. You would have gotten something that has like an x cubed in it, and you might not know how to factor that. So it's important to recognize that. And remember, we used method 2. Method 2 meaning I found the LCD for all the fractions that appear and then multiplied it to every single fraction we had. If you use method 1, remember, method 1 means add through the numerator, get a single fraction, keep the denominator, or get a single fraction down the denominator, and then multiply by the reciprocal as you normally would when you divide fractions. Personally, I prefer method 2, but like I said, you can pick the method that you would like.